Hello everyone, welcome back to my channel Tech Tutor. Today I'm going to help you stand up a Mongo database using Docker, and then after that we're going to use Spring Data to interact with the database, which will give you a way to add records, delete records, or even search for records. So if you've never heard of Mongo database but you wanted to try it, this video will help you get started quickly, and then if you want to have more details about Mongo database later, I can make a video on that, but this one will just help you get started by setting up the database and interacting with it. First, let's take a look at this POM file. As you can see, I am using Java 11. And for this example, I am only using 3 dependencies. These dependencies are Spring Boot Starter Web, which will help us spin up a simple web server on port 8080. Spring Boot Starter Data MongoDB. This will help us with our basic repository needs to interact with MongoDB. And then we're using Lombok, which will help us with some of our Spring classes for getters and setters, as well as to wire in our dependencies, the beans that we've created, into the classes. So if you're wiring in a repository or a service or other beans that you've created, this will basically help you with that. Next, let's take a look at our application.yaml file. In this file, you will see that I have added this include message always. I'm doing this so that way I can display error messages when an error is thrown for the controller. So you won't only just get basically a 400, you'll also get the details of that error, or if I return a 404, it will also have the details of that error as well. I will showcase that in just a bit. Next, I'm also configuring some of the MongoDB properties. So I'm using auto index creation. This way it'll automatically create indexes based on different annotations that I'm adding into the document file. If you don't turn these on, it will not create the indexes, so this is very important. You can configure the name of the authentication database. The default is admin, but I have it here just in case you wanted to change it. Then I'm going to make the user tech tutor, the password, the name of the database will be stores. The port is 27017. This could change, but this is usually the default port, and it's also the port in our Docker image, as well as the host. Because we're going to run this locally, it'll be localhost. Now let's take a look at the Docker Compose file. I'm using the latest image for Mongo, and I will put a link in the description to where you can find this image and the details about it, as well as what you can configure with it. I'm going to be configuring the username and password for root, so I'm going to set it to tech tutor and password. That way the values we were setting in that application YAML will work. The ports that need to be exposed, again, the default ports 27017 is the typical port for Mongo. And then I'm creating a volume so that way I can persist the data that will be stored in the Mongo database somewhere on my computer. So basically this, again, will persist the volume until you tear it down. So you can actually, again, bring this up, tear it down, and delete all of your data, or you can keep it and it will persist on your computer until you wipe it away. Now let's take a look at the store controller I've created. So I've decided to create a controller, and in this sample, it's going to basically allow you to add and remove or look up stores. So we have a few different APIs here. I would suggest adding a service layer and putting your repository dependencies into the service class. But for this video, I'm going to keep it simple, and I'm just going to wire in this repository directly into the controller just to keep this to fewer classes for the video. I have a REST controller annotation, so that way I can automatically use some of the pieces that Spring has created for me to serialize, deserialize values coming in, and again, setting up the controller APIs, as well as supporting the fact that if I throw a exception from this method out, it will automatically turn this into a response. I'll drill down into this resource not found exception in just a moment. You can also see that I'm using required args constructor. Required args constructor is part of Lombok, so that way I can do private final store repository instead of saying auto wired. This is your choice. You don't have to use it, just my preference. And then I'm mapping this API where the base of the API is going to be /store. So again, going through this, we have an API to find all of the stores. We have an API to find the store by the ID or else throw my custom exception. The reason why it is or else throw is because this actually returns an optional, and this is something that I have automatically wired in from the store repository. The store repository has some automatic methods that are available for you. Basically, it's part of Spring, and as long as you're extending a certain class, you'll get some methods right out of the box, and you don't have to write every single method manually. I'll get into that in just a moment. And then we also are using an API for getting the store by email. This is because I've also created my own method to find email, because it's not one of the default methods that would be available for the repository. A way to save, so that'll be our post. A way to delete. And then also our last piece will be something to search our stores by the search text. So I'm putting some default values to kind of prevent the user from messing up and doing something they shouldn't be doing. They still could potentially put invalid values. You could even put validation to prevent some of that, or at least guide them in the right direction. But basically, I'm not making these items required because I have default values for them. And so the idea is that you want to have them pass a search text, so that way you can search the indexed fields. Because I'm going to be using a paging and sorting repository, you will be able to page through results. You're always going to want to start at 0 unless you're trying to pick up in the middle of your search results. And then the page size, I'm going to default it to 1 if they don't specify it, but you would want to be able to make this potentially configurable. So you could put it in a property, or maybe you allow the user to change it like I'm allowing them to. This is up to you. And then this is kind of how it looks like for if you wanted to search the index fields. You're going to pass in a text criteria, and I'll get into this query in just a few moments once I jump to the repository class. Now in the store class, you'll see that I have different field values. These values are going to be stored in our Mongo document. You can see that I'm using the data annotation to create getters and setters, and the document annotation to mark the class as being a domain object that we want to persist into our database. If you don't do this, it won't get created in the database. It won't work when you try to save it. Basically, it's just not going to fulfill the minimum requirements that Spring needs to know that this is going to be something you're saving or retrieving from the database. And then this ID annotation will automatically generate an ID value for the ID field. You could change this, but I'm just keeping it simple and intuitive by naming it ID. And then I'm indexing the fields with this text indexed annotation. This will allow me to search these fields automatically with my text criteria that I'm passing in. Otherwise, it will not search those. So you'll see later that I actually do have a way to still search for email, but it's not going to be the same as it is for these fields. And then also I have this annotation field, which allows you to actually override the name of the field that will be in your document. So it will not actually store email in the database. It'll store it as contact. I'm just doing this to showcase it. It's not something I typically do, but just wanted to show that you can do it. And then this has no annotation, but it will still save it in the database as email verified, and I'm defaulting the value to false. And then lastly, there's this text score annotation. The text score annotation marks the property to be considered as the on-server calculated text score when doing the full text search. So when we do a search later on the indexed fields, this score value will change based on the relevance that it thinks that the search results have to what you're looking for, to try to give you the best results based on the search that you've provided. And then as you can see, I've also added this custom exception class to inform the user when records are not found in the database. So I'm using data to create getters and setters for it. And then response status, this is where it is going to be setting the response status as 404 not found. And then I just created a message structure where I could pass in the resource name, the field name, and the field value. And then I'm extending the runtime exception. So then when I throw this from the controller, it'll automatically wrap it in a 404 along with this message right here. Next, let's go take a look at the store repository. You can see that I've added an extra function to find the email. As I mentioned earlier, Spring will know what this means based on a specific naming convention. So when I was saying that there's certain things built into the Spring Data library, basically they've made it to where if you use certain naming convention of these methods, it automatically knows how to generate a query to pull back these values. If you have the Enterprise edition of IntelliJ, I know that it actually does try to help you by suggesting what these values might be. In the Community edition, it's not as nice, but you kind of get the hang of what these naming conventions are, and you should be able to kind of write these with no problem. Additionally, you can override these, and actually there's an annotation to put actual queries instead of doing this dynamic query by name. But I like to do it this way. It's simple. Again, unless you have a more complex query, I would just suggest doing what is built into the Spring Data library to help you generate queries. And then I also have this find all by, which this method is going to take that text criteria that we're inputting as well as a pageable value to allow us to page through the results and basically do that search on the indexed fields. I almost forgot, additionally, as I was saying, to take advantage of the Spring Data library and how you can get these built-in functions. You're going to want to extend Mongo repository, and it's going to expect the POJO that the document is coming from. So again, this came from that store class. And then it's also going to expect the ID type, which will be string. So if I drill down in here, it also basically says that as well. It's wanting to have the type and the ID. Now let's go ahead and spin up our Docker container. So go over to our Docker Compose file and then say open in terminal, and then Docker Compose up-d. And if you have not already downloaded the Mongo image, it will download it and then it will run it, and you'll see that it is running. You can verify this with Docker PS, and you'll see that it has been running for 10 seconds. Now there's one more property that I almost forgot to add. Let's go ahead and add this to our application YAML. This property is going to help you if you're not familiar with MongoDB and how the queries are formed. If we add this property, it will also tell you the queries that it's executing when you run the different APIs we've created in this project. So it'll kind of tell you what Spring did for you in those queries that it's running. So let's go ahead and add that now. So it'll be logging level org Spring framework data MongoDB core Mongo template, and then the value is debug. Go ahead and save that. And again, when we run our project, this will allow us to see the queries that it is going to execute. Now let's go ahead and run our project. So go ahead and right click Mongo application and click run. And then I like to use Postman to hit my APIs. So that's what I'm going to use. I'll open up Postman. All right, so in Postman here, I've got some APIs that I went ahead and set up ahead of time to save time. So we'll go ahead and hit our first API of getting all the stores. You'll see that there are no results as expected because we haven't added anything into the database. So let's go ahead and add something now. So the body of my message will have 3 stores because I'm taking in a list of these store objects. And so then the name of the first one, Tool Depot, Pet World, and Furnitureland. So let's go ahead and add our 3 stores. As you can see, the ID was generated for all 3 of these, and it returned the results. The score is null because I'm not actually utilizing the search query yet, and the default value of false was added, so that's good. And it is still showing email and not contact here because Jackson is going to use the object to serialize and deserialize the results coming in and out, but the database itself, when we go check that later, you will see it actually is contact. So let's go back to get all stores, and we'll run that, and now you'll see we have all 3 results. So our next API, this one is the search API, where I showed that you could do pagination and it will also score your results. So I've already added a search text in here just for the example, so I'll go ahead and click send. So I'm passing in tool need as the search text. The page is 0, meaning we're starting on the first page, and I'm expecting a page size of 2. Well, this actually only returns 2 results that are scored high enough to come back as results. You'll see that it makes sense that of the indexed fields that we're looking at, which is name and description, all your tool needs in one place has a higher score than the furniture land. Furniture land found the need value, so it has a smaller score and it does find some relevance, but it is not a direct match. And then also you'll see that if I change the page size to 1, I will only get 1 result. And then if I want to paginate to the next result, I will change the page value to 1, and now we are on the next page. So again, Spring has made this very easy to do pagination, to do searching, and we'll move on to our next API. So if I'm going to get a store by the ID, I need an ID, and I have one right here. So let's go ahead and take Tool Depot's ID, and we'll set the value right here. And now you'll see that I got Tool Depot. So let's change this value to just something completely random. Maybe we'll just do a bunch of letters. And you'll see that it didn't find anything with the ID that I just provided, this fake ID, and the 404. This is because of that exception that I created. I told it the status value I wanted it to return and the structure of the message I wanted it to tell the user. Next, because I did not index the email, this is the way you're going to grab stores by their email. So I already have one loaded up here, which is support@petworld.com. And you can see that it actually does find a result. But if I change it to com with 2 M's, it will be invalid. This is not doing any sort of partial search. This is an exact search looking into the database. And after I've done these searches, we'll also go look into our console to see what kind of queries it ran as well. And the last thing we want to do is delete one of the stores. So let's go back and grab an ID. I guess we'll delete Tool Depot, why not? So we'll take this and we'll run it. And you'll see that I got a 200 OK. But I've also added it to where if it doesn't find the value, it will return a 404. This is because of the logic that I wrote in the controller. So that way it indicates to you whether or not it actually found a store to delete. Now let's go back into the project and take a look at some of the queries. As you can see, here's all the queries that it ran. So it did a find query, and this is the query where it was finding all the stores. You can even see here where it was doing the search on tool need, and it was getting the text score set. So that way we could order it by the text score. And I ran this several times as I was showing how you could paginate. So that's why you see it a bunch of times in here. We did a search by an ID, and then we also did the search by an ID that didn't exist. And then you can see here where it was doing that find query where it's looking for an exact match on that contact field. This is what I was talking about earlier, about how it actually saved contact to the database instead of email. But when we passed it in here, you could see that it was still taking email, again, because Jackson is looking for it to match the value in our code, but the database has actually stored it as contact as expected. And then lastly in here, you will see our delete query in action. So it ran the delete query here on the ID and it was successful. And that wraps up this video on Spring Data for MongoDB. Obviously, there's a lot further in depth that you can go. I'll put a link in the description to the documentation. I kept this pretty easy. I just wanted to show you how you could spin up a database very quickly and then interact with it, save things to it, delete things from it, and then how you could also search index fields and how it will score the results. I think this is a very easy way to get started with MongoDB. It was much more difficult in the past. Docker has also made it easy because you can now spin it up and spin it down with just this Docker compose file. So you don't have to run the manual executables on your computer and then, spin things up and down with those executables. So in general, this will help you get started in probably 10 minutes or less. If you'd like a video that's more in depth in the future, let me know. And please like and subscribe for future content. Please let me know if you have any questions. I will be happy to answer them in the comments.